Hello everyone. Today we're going to start with the concept of projectile motion. So as you all know that you might have observed projectile motion in your daily life. So for example, when you kick a football to the another player, you will see the parabolic path being followed by the football. So that is an example of projectile motion. Another example can be when you throw something towards another person standing a bit far away from you, you will see that the object is following a parabolic path. Now, why this happens, why the shape of the path is parabolic path? So the reason is that the object is projected into the air and it follows a path which is affected by none other than the acceleration due to gravity, which is acting just towards the center of the earth. So let's start with exploration of few projectile motions. Now, the type of projectile motion we're going to explore today is horizontal projectile motion. Now, to study the various components involved in this motion, we have to first split the components of all the vector quantities into horizontal and vector quantities. Now, before I go into the different components of velocity, acceleration, or displacement, let me first introduce you or explain you a bit about vector and scalar quantities. As you already know that vector quantities are those physical quantities which have both direction as well as magnitude, whereas scalar quantities are those which have only the magnitude and don't have direction. Now, for example, if I say that time, now time is a physical quantity in which you don't talk about the direction of time, right? Now, but when you talk about displacement or velocity or acceleration, you always talk about the direction of velocity, like in which direction your velocity is this, your speed is this. Speed is a scalar quantity, but if you mention direction with the speed, that means that is a velocity, right? So all the vector quantities can be split into horizontal and vertical components. So in our situation, in this horizontal projectile motion, we can split displacement, velocity, and acceleration into the components, but the fourth physical quantity involved in this motion would be time. Now, because we know that time is a scalar quantity, we can't split time into the horizontal and vertical components. Now, let's have a look at the horizontal component of displacement. So as you can see in this diagram, this r is the horizontal component of the velocity, whereas if I talk about the vertical component of displacement, that is h. Now let's split this initial velocity into horizontal and vertical components. Now as you can see in the diagram, you have projected the object in the horizontal direction. That means you only have the horizontal component of velocity, whereas your vertical component of velocity over here is 0. Now, when you project this object into the air, the only acceleration that is being experienced by this object is acceleration due to gravity, which is always vertically downwards towards the earth. Whereas you don't experience any acceleration in the horizontal direction. That means your horizontal component of acceleration is 0, whereas your vertical component of acceleration is nothing but acceleration due to gravity if you are observing the projectile motion on Earth. For example, you're observing the projectile motion on any other planet, so you will be taking acceleration due to gravity on that planet. Okay, so that's about the horizontal and vertical components. Now, how can you calculate the vertical height of the projectile motion? Now, see, when I say vertical height, that means you have to consider only and only vertical components. Just forget about the horizontal components. Now, you have to apply one of the equations from three equations of motion. So here I'm going to use s equals to ut plus half at squared. Now you can see that I have used these subscripts as y. Now y means vertical direction. Now I know that my vertical component of velocity over here is h, whereas my initial vertical component of velocity was 0, so that is why I have substituted 0 for that. My not horizontal, but the vertical component of acceleration is acceleration due to gravity, so I substituted g. So I will get the equation as h equals to half gt square. Now in some questions they will give you height and they'll ask you to find the time of flight, and in some other questions they may give you time of flight and you have to find the height of the object from the ground. Now, how can you find the horizontal range of the motion? So before we do horizontal range, you should know what is horizontal range. Horizontal range is the horizontal distance from the initial point to the point where it falls like on the ground. So in this diagram, this R is our horizontal range. Now I say horizontal range, that means I have to consider only the horizontal components. Again, I'll apply the same equation of motion, S equals to ut plus half at square, but I'm using the horizontal components. That's why I'm using the subscripts as x, right? Now my sx over here is the range r, whereas ux was my initial velocity with which I was projecting my object in horizontal direction, that is u. T is the time of flight. Now because my acceleration due to acceleration in the horizontal motion is 0, so my range comes out to be velocity times time because of 0 acceleration in the horizontal direction. Now in some questions you might come across a question which might ask you to find velocity at any arbitrary point during the motion. So let's say if you have to find the velocity at point C. Now if they ask you to find the velocity, they may ask you to find the horizontal component of velocity at point C or vertical component of velocity at point C. But if they just say find the velocity at point C, then you have to work out for the resultant as I have done it over here. So the first thing is that you will find the horizontal component of final velocity after time t, and for that I am going to use this equation of motion, which is v equals to ux plus axt. But why I'm using subscript x? Again, the reason is horizontal, right? So now I know that my ax is 0, so my equation becomes vx just as u. That means during the whole motion my horizontal component of velocity will never change. Now let's jump to vertical velocity. For vertical velocity, again I'm using the same equation of motion. Again I know that my uy, that is my initial vertical component of velocity, which is 0, whereas my vertical component of acceleration is g, and after substituting the values I will get the vertical component of velocity after time t as gt. Now I know that I would be applying vector analysis over here to find the resultant velocity, because it is a vector quantity, so my resultant would be square root of vx square plus vy square. Now substituting the value of vx and vy, I would get this resultant. Well guys, I hope you understood the relationship between different physical quantities related to horizontal projectile motion, and if you like the video, then please press the bell icon and also subscribe my channel for more upcoming videos. And in the upcoming video I will be dealing with different graphs related to horizontal projectile motion, and that will follow angular projectile motion. Thank you.